So today we'll be looking at binary operation. What is binary operation? It is a mathematical operation that combines two numbers or values in a particular way. The major types or forms of binary operations we have addition or adding, minus, multiplication or to multiply, and then division, that is to divide. These symbols can combine numbers or values in a particular way. So what do we mean combine? So let's say if we have 2 plus 4, we all agree that is 6. If we are to have 4 minus 2, that is going to give us 2. 4 times 2 is 8. 8 divided by 2 would give us 4. So we already know the rules that we use when we are combining numbers using addition, minus, multiplication, and division. But these signs have some properties, and that is what we are going to study today, which we know as properties of operation. And the first one we will be looking at is commutative property. When we say commutative property, we are referring to the property or the nature of a binary operation whereby the values can be interchanged and still give us the same answer. Okay, so if A and B are numbers, and then star here is an operation combining A and B, then we can say that star is commutative only if A star B would be equal to B star A. We can put this into perspective. So this star is standing in for any of these four operations, and A and B are standing in for numbers. So we are going to try this for all these four operations and see the ones that have the commutative property. But for the sake of reference, we need to keep in mind that it is only addition and multiplication that have commutative property. Now let's test it out and then let's see. Let's assume A is 5 and B is 2. Let's work this out and see what we are going to have. So star will be changing from addition to multiplication to subtraction and then division. So first we are going to have 5 plus 2 should be equal to 2 plus 5. So 5 plus 2 would give us 7, which should be equal to 2 plus 5, which is also 7. So we could agree that A star B and B star A in the terms 5 plus 2 equals to 2 plus 5 are giving us the same answer. Therefore, addition is said to be commutative. Let's try that for multiplication. 5 times 2 should be equal to 2 times 5. 5 times 2 is 10 and is equal to 2 times 5, which is also 10. So since we have the same answer, we can say that addition and multiplication are commutative. But we cannot say the same for subtraction and then division. Let's try it and then let's see. So 5 minus 2 cannot be equal to 2 minus 5. Why? 5 minus 2 is 3. 2 minus 5 is negative 3. These two numbers are not the same. So they are not, so subtraction is not commutative. Let's try with division. 5 divided by 2 is not equal to 2 divided by 5. 5 divided by 2 is going to give us 2.5. 2 divided by 5 is going to give us or would give us 0.4. These two numbers are not the same. We can try for the sake of divisions for us to have proper numbers. Let's try 10 divided by 2, then 2 divided by 10. 10 divided by 2 is 5. 2 divided by 10 is going to give us 0.2. So again, the answers are not the same, and therefore they are not commutative. So let's keep that in mind. It is only addition and multiplication that are commutative, and we test that by interchanging the values we have to add, as we can see here. Let's move to the next property of operation. Here we have associative property. Associative property is a property of an operation which proves that the sequence of operation on 3 numbers or more would not affect the outcome. In other words, we had A star B star C. On the left hand, we can see that B star C was operated on first, and the answer was operated on A star. And this is what we do when we have BODMAS. We solve what is in the bracket first. So BC was solved first, and the answer will be solved on A. And it will be equal to the instance on the right hand side where A star B is solved with star C. Okay, and we are going to test this on addition, subtraction, multiplication, and division. And all again, it only works for addition and multiplication for reference sake. So let's keep that in mind. We are going to pick A, B, C and give them values of numbers, then test them on the operations we have there. So let's just say that A is 2, B is 3, and then C is 4. A is 2, B is 3, and then C is 4. So we are going to put them into these expressions starting with addition. So we are going to have 2 plus, into brackets, 3 plus 4. Then we will be having on this side 2 plus 3 plus 4. We have to solve what is in the bracket first. 3 plus 4 would give us 7. On the right hand side, 2 plus 3 would give us 5 plus 4. Now 2 plus 7 is going to give us 9. And 5 plus 4, 9. So we could say that addition is associative. Now let's try the same for multiplication. 2 times 4 times 2 times 3 times 4. We solve the latter first. On the right hand side, 2 times 3 times 4. We solve 2 times 3 first. So according to BODMAS, we need to solve what is in the bracket first, and that is going to give us 12. 2 times 12 is 24. On the right hand side, 2 times 3 is 6. 6 times 4 would give us 24. So we can say that addition and multiplication are associative, but we cannot say the same for subtraction. 2 minus 3 minus 4 is not equal to 2 minus 3 minus 4. If we solve the latter on the right hand side first and the former on the right hand side first. So in this case, we are going to have 2 minus 3 minus 4 is negative 1. So 2 minus minus 1 would give us plus 1. And that is 3. On the right hand side, 2 minus 3 would give us minus 1 plus 4. That will give us minus 1 minus 4. Minus 1 minus 4 would be minus 5, and we can see that it is not the same. If we should try for division, 2 divided by 3 divided by 4 Okay, to get whole numbers, let's try using values that are easily divisible. So we will be using 100, 20, and 10. Let me look for a better way to write this. So on the left hand side, would we have 100 divided by 20 divided by 10 would be 2. Our answer on the left hand side would be 50. On the right hand side, we would have 100 divided by 20, and that would be 50. 50 divided by 10, that would give us 5. And we can tell they are not equal, just as in the case for subtraction. So we can come to a conclusion that whilst addition and multiplication are associative, division and subtraction are not associative. Now we'll move on to another property, which is distributive property. When we say distributive property, here we are dealing with two operations. We are dealing with two operations on a set of numbers, where we have to deal with one operation first in a bracket before it works or it combines with the number outside the bracket using another operation. And we can say that it is it is distributive, okay, if we could work with each number in the bracket with the outside one first and still get the same answer, just as we can see here. So in this case, we have star A being distributed over B and then being distributed over C. If it happens that any two operations can work this way and still give us the same answer, then we can say that they are distributive. So we are going to just come to a conclusion here that multiplication is distributive over addition and subtraction, but division is not, and the reverse is not the case. So if I should have two numbers here, or let's say three numbers in this case, where we have A to be 2, B to be 3, and C to be 4. We could put them into this operation where we have 2 times into bracket 3 plus 4. Then on the other side, 2 times into bracket 3 minus 4. So we are testing for addition. Okay. I'm going to split this up. Over here, we are going to distribute 2 times on 3 and then 4. So in our distribution, we'll have 2 times 3. That is our first distribution. Then plus our second distribution would be 2 times 4. Let's work this out. We'll get to the subtraction later on. So we'll work the left hand side first, then we'll work the right hand side first. So this would give us 2 times 3 plus 4 is 7. Now we have 2 times 7, and that will give us 14. Let's test for the right hand side and see if we also have 14. 2 times 3 is 6, plus 2 times 4 is 8. When we sum these up, we are going to have 14, so we could tell that they are equal. So multiplication is distributive over addition. Let's try for the right hand side. So that is going to, we are going to distribute 2 over 3 minus 4. So that will give us 2 times 3 minus 2 times 4. We are done with our distribution. So going on, we are going to have 2 times 3 minus 4 would give us negative 1. When we multiply, our answer becomes negative 2. Positive times negative is negative. On our right hand side, 2 times 3 is 6 minus 2 times 4 is 8. So now we have 6 minus 8, and that also gives us negative 2. So here we could conclude that multiplication is distributive over addition and subtraction. Now we'll also look at closure property. What do we mean by closure property? If an operation performed on elements of a given set gives answers that are members of the given set, then the set is closed under the operation. There are a lot of considerations under this particular property, and we would like to look at the set of numbers. So we have natural numbers, which are n. These are numbers that begin from 1, 2, 3, 4, and then it goes on to infinity. Then we have whole numbers. These are all natural numbers, including 0. So that is 0, 1, 2, 3, 4. It goes on till infinity. Then there are also what we call rational numbers. Rational numbers are numbers that can be expressed as fractions. So we would have both fractions and then whole numbers. They would give us what we call rational numbers. Then we also have what we call real numbers. All numbers you could think about are all real numbers. Any number you could think about, okay, is a real number, except for those we cannot calculate. And then we also have irrational numbers, integers, and so on. So I'll end with integers here. So integers are all positive whole numbers and negative whole numbers. So it starts from say negative infinity, then we have negative 2, negative 1, 0, 1, 2, and continues to positive infinity. So all numbers we could think about that are whole numbers, we call them rational numbers. Now, why are we studying this? We are studying this because the 4 basic arithmetic operations are not closed under all of these. Okay. Only the set of integers, rational numbers, and real numbers are closed under subtraction. Okay, only the set of integers, as we have here, integers, are closed under subtraction. Okay, I mean the set of integers, rational numbers, and real numbers. So integers first, we have rational numbers, and then we have real numbers. So rational numbers, real numbers, and integers are all closed under subtraction. But when we come to addition, natural numbers, whole numbers, integers, real numbers are all closed under addition. We could also say to some extent natural numbers are not closed under addition. Okay, because we could add two numbers and have 0. For instance, -2 plus -1 would give us 0. But then again, they are closed under natural numbers, because if we pick natural numbers and we do our addition, all numbers we are going to obtain will be found in natural numbers. But that is not the case for subtraction. Okay, we may have negative numbers when we do subtraction, and we are not going to have negative numbers in natural numbers. Same for whole numbers, we do not have negative numbers in whole numbers. For instance, if I should pick these two members of whole numbers, say 3 minus 4, that is going to give us -1. -1 cannot be found in the set of whole numbers, so it is not closed. All right. Now, when we come to multiplication, we could conclude that almost all the sets of real numbers are closed under multiplication. Okay, almost all the sets we have here, because if we pick natural numbers, or every number we can obtain by multiplying, the members of natural numbers would also give us a natural number. If we pick whole numbers, any two numbers that are whole numbers, when they multiply, would give us an answer that is also a whole number. The same would go for rational numbers, real numbers, and integers. But for division, okay, if the set doesn't contain 0, then it cannot be closed under. If the set doesn't contain 0, it cannot be closed under division. So with that, we could conclude that the set of natural numbers, whole numbers, integers, and rational numbers are therefore not closed under division. So we are to note that when we say the set of integers is not closed under division, this is because not all integers, when divided, give an integer. For instance, if we divide 2 by 3, we are not going to have an integer. When we include 0, the set of rational numbers is closed under division. Okay, so when we exclude 0, then it goes on and on and on. So we could say that none of these numbers, or none of these set of numbers, are closed under division, with the exception of real numbers. Okay, so real numbers are closed under division. But all the same, you cannot just memorize this. Usually when you're given exercises, you'll be given a set of numbers and the operation will be defined. When the operation is defined, you have to test the answer you have against what you have in the set to see if it is closed under the set or not. Okay, so this is how we go by. Now let's move on to identity property. When we say identity property, we are looking at usually what we call elements or a particular value. So let me put 4 here. What do we have to add to 4 to get 4? That is what identity property is saying. So the element that will work with an operation to produce the same value it worked on before is what we call the identity element. So if I should add 0 to 4, my answer will still be 4. If I should subtract 0 from 4, my answer will still be 4. So the identity element, using E to represent identity element. So the identity element for addition and subtraction is 0. When we go for multiplication and division, the identity element E is always 1. For instance, 10 divided by 1 is 10. 15 times 1 is also 15. Okay, so for identity element, we are asking which number will this operation need in order not to have an effect on the value it is working on, or which value can work with this operation so that they don't change the values of the other numbers they are working with or they are being combined with. And it's as simple as that. 4 plus 0 would give you 4. 4 minus 0 is still 4. 10 divided by 1 is still 10. 15 times 1 will still give us 15. So when we say identity element, this is what we mean. Then we have the inverse. So the inverse property, or again element, is the value that an operation combines with any given value to give us its identity element. So when we pick addition and subtraction, the identity element is 0. So if I should pick 4, the inverse element for 4 in terms of addition should be negative 4. And that will give me the identity element, which is 0. If I should pick 5, the inverse element for subtraction would be the number itself. And that would give me its identity element, which is 0. So in other words, when we are adding numbers or for addition, the negative of the value is its inverse element. And when we are dealing with subtraction, the value itself is its inverse element. Now let's come to multiplication. We know that for multiplication and division, the identity element E is 1. So if I should have 6, what do I multiply by 6 to get 1? That will have to be 1 over 6, which is the same as 6 inverse. For division, what do I divide by 6? In order to have 1, I have to divide 6 by itself. So the identity element for multiplication and division is 1. So when I pick up multiplication, its inverse element is the inverse of the number. And that would give us 1. So 6 times 1 over 6 is 1. 10 times 1 over 10 is 1. 15 times 1 over 15 is 1. So if I should have 15 times 1 over 15, what does this give me? 15 always has a denominator of 1. So 15 times 1 would give us 15. 1 times 15 will also give us 15. When we cancel out, our answer is 1. This is what we mean by inverse property or inverse element. Okay, so basically these are the 6 properties of operation, which is going to help us in our journey of mathematics. Let's conclude this by solving this example. So here we are working with defined binary operations. It is not always that we will be given addition, subtraction, or simplified binary operation. In some cases, the operation will be defined for us, like the case we have here. We are being told that m star n is solved in the form m plus n plus nm. This is multiplication. That is n multiplying m. In other words, whatever value m and n is, once they are using the operation star, we first have to add them, then add their product to them. And we've been asked to evaluate 3 star 4. So this is supposed to give us 3 is standing in for m, 4 is standing in for n. So this is the formula we are using, and we are supposed to go by this strictly. We do not change anything. We have to go by it strictly. So this is going to give us 3 plus 4 plus 3 times 4. Okay, like I said, When we see two letters adjacent to each other in mathematics, they are multiplying. So 3 is standing in for m. So anywhere we have m, we put 3 there. And 4 is standing in for n. So I have to interchange this to 4 times 3 because we have m times n. And solving this out, 3 plus 4 would be 7. And then 4 times 3 would give us 12. So when sum these up, our answer would be 19. Now we've been asked to do the inverse of that, and I think that will remind us of a property we just looked at earlier. Now we have m to be 4 and then n to be 3. So we go back to our formula. M is 4, so we are going to have 4 plus n. N in here is 3 plus n times m. So that would give us 3 times 4. So 4 plus 3 is 7. Now we have to multiply this. 3, 4 would give us 12. Our answer is 19. Now for B, we are being asked to say something. What can you say about I and II? We could come to a conclusion that from the answers in I and II, since they are equal, then we can say that star is commutative. Okay, so that is commutative property. That is what we are being shown here. So let's just state that the answers in I and II are equal. Therefore, star is commutative. Now we've been asked to show that 2 star 3, 2 star into bracket 3 star 4 equals bracket into bracket 2 star 3 bracket close star 4. We are being asked what property is this. We can tell that this property is associative property. So if we work on this and we have our answers to be the same, then we can say that this is associative property. So first, what do we solve first? We have to solve what is in the bracket first. So that would be over here 3 is m, 4 is n. And keep in mind that we already solved 3 star 4 and that gave us 19. But we are going to use the same approach. So that would be 3 plus 4 plus 4 times 3. On the other hand, we have 2 star 3 and that will give us 2 because 2 is m, 2 is n. We are solving what is in the bracket first. So we have 2 plus 3 times 2. Then outside this bracket, we have star 4. So we are solving what is in the bracket first. So this would give us 2 star 3 plus 4 is 7. 4 times 3 is 12. Then we have 2 star 3 plus 4 is 19. Now this becomes m, this becomes n. And that will give us 2 plus 19 plus 19 times 2. 2 plus 19 would give us 21. 19 times 2 would give us 38. So in some days we are going to have 59. Now we can do the same thing for the right hand side. So this would give us 2 plus 3, which is 5. 3 times 2 would give us 6. This would give us star 4, not to forget about that. This would give us 5 plus 6, which is 11. So now we have 11 star 4. Now 11 is m, 4 is n. When we expand, we are to have 11 plus 4 plus 11 times 4. 11 plus 4 is 15. 11 times 4 is 44. When we sum this up, we are going to have 59. So we can conclude that, therefore, star is associative. Right. Now we are supposed to deal with D, and we've been asked to form a table for star on the operation 1, 2, 3, 4, on the set 1, 2, 3, 4, not on the operation. So we'll draw a table here. We have star, then we have 1, 2, 3, 4, 1, 2, 3, 4. So from the first set here, what do we have? We have 1, star 1. So we'll have to solve for this. Then we'll have 1, star 2. We'll have to solve for that. And 1, star 3. 1, star 3. Then we have 1, star 4. 1, star 4. Then we'll come to 2. 2, star 1. 2, star 2, star 2. 2, star 3. And then 2, star 4. So 1, star 1 would give us 1 plus 1 plus 1 times 1, according to the formula we were given earlier on. A star B is equal to, according to the formula we were given, M star N equals M plus N plus M times N. So in that respect, we are solving this. There was no multiplication there, although it is multiplication. Right, so this is going to give us 1 plus 1, which is 2. So 1 times 1 is 1. Our final answer is 3. Over here, we are going to have 1 plus 2 plus 2 times 1. And that is going to give us 1 plus 2 is 3. 2 times 1 is 1. 2. And our answer is 5. So we would have 3 here, 5 here. 1 times 1 star 3 would give us 1 plus 3 plus 3 times 1. And that will give us 1 plus 3, which is 4. 3 times 1 is 1. 3 times 1 is 3. And our answer would be 7. Next we have 1 plus 4 plus 4 times 1. 1 plus 4 would be 5. This should be plus. Then plus 4. And that would give us 9. And we move on. This would be 2 plus 1 plus 1 times 2. 2 plus 1 is 3. 1 times 2 is 2. And that would give us 5. So you realize that 2 star 1 is the same as 1 star 2. Now we have 2 plus 2 plus 2 times 2. 2 plus 2 is 4. 2 times 2 is also 4. Then the answer would be 8. On this side, I bet it would be the same as 3 star 2, but let's solve for this first. So this will give us 2 plus 3 plus 3 times 2. And that would be 2 plus 3 is 5. 3 times 2 would be 6. And the answer would be 11. Then 2 star 4 would be 2 plus 4 plus 4 times 2. And that will give us 6 plus 8, which will result to 14. So let's complete the table as we have solved so far. So this would be 7. 1 star 4 would give us 1 star 3 was supposed to be 7. Let's write that below. And 1 star 4 would give us 9. 2 star 1 was 5. 2 star 2 was 8. 2 star 3, 11. 2 star 4 was 14. Now we are going to start with 3 star 1, then 3 star 2, then 3 star 3, then 3 star 4. We've almost solved for all of these, but we'll do that again just to confirm. So this would give us, according to the formula, 3 plus 1 plus 1 times 3. 3 times 1 is 3. 3 plus 1 is 4. And 1 times 3 is 3. That would give us 7. Now 3 star 2 would give us 3 plus 2 plus 2 times 3. 3 plus 2 is 5. 2 times 3 is 6. And that would be 11. Now 3 star 3 will give us 3 plus 3 plus 3 times 3. 3 plus 3 is 6. 3 times 3 is 9. That would give us 15. Now we have 3 star 4 would give us 3 plus 4 plus 4 times 3. Now 3 plus 4 is 7. 4 times 3 is 12. Our answer is 19. Now we are moving on to 4. So 4 star 1, 4 star 2, 4 star 3, 4 star 4. The 4 star 1 would be 4 plus 1 plus 4 times 1. That would give us 5 plus 4, which results to 9. 4 star 2 would be 4 plus 2 plus 2 times 4. And that would be 4 plus 2 is 6. 2 times 4 is 8. And that would result to 14. Then we have 4 plus 3 plus 3 times 4. 4 plus 3 is 7. 3 times 4 is 12, and that would give us 19. So we can testify again. We can testify again that 4 star 3 is equal to 3 star 4. Okay. Now we have 4 Let's put in our 19. You can see 4 star 4 will give us 4 plus 4 plus 4 times 4. 4 plus 4 is 8. 4 times 4 is 16. And what would that give us? That is going to give us 24. Now, if you look at this carefully, we will be able to identify some repetitions in the diagonals. Okay, so in most operations, we have 3, we have 1, 1 here, 2, 3, 2, 3, 5, 5, 3, 4, 7, 8, 7, 4, 9, 11, 11, 9, 14, 15, 14, 19, 19, and then 24. So this is the fun of working with binary operation. More examples will be solved and posted on the page. If you were able to watch to this far, well done, and see you in the next video. Stay blessed. God loves you.